Since we are done with the distance time graph, now I'm moving with velocity time graph. Now velocity time graph, when I say, it is represented by the velocity on the y-axis and time on the x-axis, just like our previous distance time graph. Now as I have said, I will draw the y-axis for the velocity, the x-axis for the time, and we denote v velocity as v only with its SI unit meter per second. Now when an object is in uniform motion, my first part is object in uniform motion. When an object is in uniform motion, that means the object is not changing its velocity with time. It is having a constant uniform velocity. So with time, the velocity, a particular value of velocity will remain the same. So suppose a velocity v we take over here, and this velocity is going to be same for the rest of the time. So we see that in a velocity time graph, an object in uniform motion, if the graph is plotted, it is plotted as a straight line parallel to the time axis or x-axis. The velocity time graph tells us two things. First thing is the slope of the graph will tells us about the acceleration of the body, and second, area under the graph, or we say area under the graph, will give us the distance, or we can say the displacement traveled by the body. Now to calculate the slope of this particular graph, now slope is again my previous video I have already told you the formula is y2 minus y1 upon x2 minus x1. Since my y2 and y1 are lying on the same point, so it is going to be a 0. Whereas the area under this graph, if I take 2 points A and B, for example, and I need to find out what is the displacement covered by the body during this time intervals of A and B, I need to calculate this much. Let it be x time interval, and let it be as it is there, it is a v velocity it has covered. So the area under the graph will be given by the formula of the rectangle v multiplied by x, or it can be also given as whatever is the x-axis, the time interval, multiplied by the y-axis, the velocity interval. And that is how in this case we will have a rectangular formula. If the graph is something else, then the formula will change according to the graph. Now the second case in the velocity time graph is when an object is at rest. When an object is at rest, first we'll make the VT graph, V on the y-axis with its SI unit to be written, and time on the x-axis with its SI unit to be written. Now when the object is at rest, we can see that there will be no factor, no value on this velocity 1. So if we need to plot a body at rest, such type of graph on a VT1, so the graph comes out to be an overlapping line on the time axis. Here I am using a different color sketch pen to mention that it's a line which is overlapping the time axis, and this is how it is being done. If I make you recall, in a DT graph, this same case is being drawn like this. In a DT graph, this is the case when an object is at rest, having same distance, equal distance, and say every interval of time. Whereas when this graph is plotted, so when this graph is plotted in a VT1, it becomes an overlapping line on the time axis, or we can say it is an overlapping line on the x-axis. Now, the third case which I am going to do is uniformly accelerated motion of a body, when the body is starting the motion from rest. That means the initial velocity denoted by the letter U is 0. Okay, so when we plot this graph, again going by the basics, that we draw the y-axis denoted for the velocity and the x-axis denoted for the time. Origin, velocity, meter per second, y-axis and x-axis. So uniformly accelerated motion means, as we go by the definition, it says whenever a body is increasing or decreasing. Okay, decreasing will be the retardation case. Whenever a body is increasing its velocity in a uniform manner, that means it is increasing its velocity with equal amount in equal interval of time, then we say that the body is having a uniformly accelerated motion. For example, as I have shown you in my previous videos also, that will take 1 centimeter as the time limits, and over here also on the y-axis we'll take 1 centimeter. Let's say mark it as 5, 10, 15, 20, 25 and so on. Similarly 5, 10, 15, 20, 25. So if my body is changing its velocity, since it is u is 0, so my graph is going to start from the origin. If it changed velocity of in 5 seconds with 5 meter per second, so my graph would, first point will be plotted here. Then at 10 seconds it increased its velocity by another 5, so it reached up to a velocity of 10. In 15 seconds it increased its velocity by another 5 meter per second, so it reached up 15 meter per second. And in 20 again by increasing by 5 meter per second, so it reached it over here. So we see that we get a straight line by joining all these points together on the graph. So here the slope of the graph tells me about the acceleration. So you can take any 2 points as per your wish. If I take this point over here and this point over here, so this makes a right angle triangle having its V1 as 5, V2 as 20, T2 as 20 and T1 as 5. So these are my values of V1. This is V2, this is V1, this is T1 and this is T2. So the formula as we know is V2 minus V1, that is change in velocity by the change in time. So if we put the values from here now, we will get 20 minus 5 upon 20 minus 5, which gives me 15 by 15, thus 1 meter per second square. In this graph, one more thing which we can calculate, as I told you during the plotting of the graph for a uniform motion, that the area under the graph also tells us about the distance or displacement traveled by the body. Now if I'm taking these 2 points, so my area under these 2 points will be this much area. I'm marking it with a green and shading it with a green also. So this shaded part will be the area under the graph. This much graph I've taken, so this is my distance or displacement. Now as you can see, this is a shape of a trapezium. You can either apply a direct formula for this trapezium, or what you can do, that we can divide this trapezium into a triangle and a rectangle. So solving these two also will get the same answer as of the area for the trapezium. So if I solve it over here by the formula of triangle base into height plus this rectangle area, so length into breadth. So what is the base of the triangle? This is the base of the triangle. Base of the triangle is this much. That means 20 minus 5, which will be 15. Height of the triangle, if we say, corresponds to again 20 and 5, which is again 15, plus what's the length? Length is 15, and the breadth over here on the y-axis corresponds, this breadth corresponds to 5. So when we are going to solve this out, we'll get 1 by 2 into 225 plus 75. So we get the answer as 2.5 plus 75. Now if we add up, we get 187.5 as the answer. When again I'm repeating that the triangle area was given by half base into height. Base was 15, height was also 15. The length of the rectangle, the length was 15, whereas the base was 5. So half into 2 to 5, which is the product of 15 and 15, and 15 into 5 is 75. When we add up these two terms, we get 187.5. Here, now since we are already given with meter per second and second, thereafter we can write this area is denoted by the 187.5 meters. So this much displacement has been covered by the object from the time interval of 5 seconds to 20 seconds. I will show you to get this answer 187.5 also from the formula of area of trapezium. Now as we know, area of trapezium is given by the formula of half multiplied by the sum of parallel sides multiplied with the height between the parallel sides. So here, if my parallel sides are going to be this and this, whereas height between the parallel sides is on the time interval. Now just putting up the values, half multiplied by first height is 5. The second height of the trapezium is 20 multiplied the distance between them. So the height between them is from 5 to 20. So 20 minus 5 is 15. I get half multiplied by 25 multiplied by 15, which is equal to 187.5 meters. So as you can see, whether we use the triangle plus rectangle formula or we use the trapezium formula, in both the cases the answer is going to be same. So whatever graph comes you, whatever shape comes for in the graph, so that particular shape, if you either can divide it into triangles, rectangles, squares, according to your preference, or an actual trapezium as per the graph.